All right, page 285. Should have, and I know I say this a lot, but you should have like 25 or 30 minutes to work on your assignment today. 285, questions. Problems you want to see worked off the homework.
49.
49. Problem 49.
Oh, those are the harder ones, Brian.
Those are the only ones I can
Can you see that yellow?
not good easily.
Yeah, it should turn the lights back off.
Turn off the light.
That's why I changed it to yellow.
Turn that lights on that.
Problem 49. No, I can't see the book. Says graph the line that satisfies each condition. So we need a coordinate plane. And on that coordinate plane, they tell us it has a slope of 3/5. This is all reviewing from algebra. And it goes through the point -3, -4. First thing we're going to do is graph the point over -3, down 4, somewhere about in there, that's point P. How do we use the slope?
Up 3/5.
Up 3/5, up 3 to the right 5. Up 3 to the right 5, somewhere about in there. From there, up 3 to the right 5, somewhere about in there. I could hit the points. Line should look something about like that. Remember to sort of check yourself. If it's got a positive slope, the line should be going how?
Up to the right.
Up, right? Up, correct.
Yeah.
Should be going up. If it had a negative slope, then it would be a falling line going down. Other questions?
I'm confused on number 13.
13?
Just because, like, I mean, I have all the information to find the answer, it's just no.
Let's see. There are 76 boys in sophomore class of 165 students.
So you had to subtract them, take from 165.
Find the ratio of boys to girls. Now, this is, especially on like the OGT test, says there's 76 boys. They always put questions like this on there because it's confusing to people. 165 students. And they want to know boys compared to girls. Well, you can't just do 76 compared to 165. You do what Peyton said. Take 165, that's total students. Subtract off 76. To borrow there. Borrow again. So what's our ratio? Will that reduce? No, yes, maybe?
I said no.
How can you tell?
Because it's an even on the number.
You should be able to do it by 3.
Maybe by 3. Now, if you're not sure, if you have just one of the, it doesn't have to be one of the spectacular calculators, one of the little calculators, like used on the OGT. So one of these TI-30s, I highly suggest if you don't have a calculator, just get this one. This has got everything on it that you could need. I mean, it's nicer when you get to Algebra 2 to have the TI-84s because you will need them over there. Mr. A lot of the stuff that he teaches like you have this calculator, or like you have the bigger calculator. But on this calculator, if you don't like fractions, it'll do all the fractions for you. If I punch in 76, hit the ABC button, 89, so Faith can look at it. They write it like that so it looks like a fraction. If you hit equals, guess what it does for you? It reduces it for you.
So you do what?
76 over 89.
So it won't reduce. So all you do You have any fraction, I don't know, give me a number.
19.
19,
Well, I don't care. I was not gonna.
19 is a prime number, right? So let's find something that's not a prime.
18.
48,
Yeah.
32.
3.
If we have that, and we don't know how to reduce it, you hit 48, ABC button, 32, enter, and it writes it out this way for you. Now it's a little more difficult this way because it actually changes it to a mixed number. Instead of just reducing it down, it says it's 1 and 1/2. Well, if you didn't want it as a mixed number, because we're dealing with ratios and proportions right now, so we probably don't want a mixed number, how could I change that back to an improper fraction?
Add 2 to 1.
All right, you take the whole number times the bottom, add it to the top, and you get 3/2. That would be our ratio. But these will do a lot of the fraction stuff for you. It'll give your answer as a fraction. Everybody wants to grab their calculators and just do division on there. Well, sometimes if you're doing division and you want your answer as a fraction, use that ABC button and it'll give your answer as a fraction. So that way you don't have to try to say, all right, what's that decimal as a fraction? Other questions? Should be no talking. 5 terms?
5 minutes.
Yeah, probably less than 5 minutes. Write down the definitions, make sure you define them completely. You get finished, lay it on my chair, on the blue chair. All right, on this. Isosceles triangle. What's an isosceles triangle?
Triangle with 2 sides equal.
Triangle
and
with at least 2 sides congruent. Notice, any of these that you should know every single day when you come through the door for geometry. Did I put stuff up here that should be real difficult? No, this is stuff you have to know to come in here and do work each day. Congruent. What's congruent?
Same measure.
Same measure is the easiest way. What's a theorem?
Something that has to be proven.
Mathematical statement that has to be proven. Supplementary angles. Be careful.
2 angles whose sum is 90 degrees.
2 angles
Dang it.
that add up to be 180 degrees.
Come on.
Be careful on this last one. An acute angle. What's an acute angle? Don't give me the...
79 degrees.
It has to be in between 90 and 0 degrees.
All right. An angle whose measure is between 0 and 90 degrees. And you say between, and then it works out. Don't just say less than 90 anymore. That's the 4th or 5th grade definition. Because there are negative angles. We haven't talked about them, but you could have a negative angle. So you need to know the others.
Gosh, Garfunkel and It's 80 degrees.
Oh, this is a big thing. Let somebody else do it.
Emma could be doing it right now.
Emma can do it on mine.
All right. What we're going to cover today is similar polygons. Go ahead and start copying this down.
This is part of the note.
Yeah, your notes today is the 24th. We're going to decide if polygons are similar. I'm going to tell you how to do that. Probably the hardest thing is right here, the scale factor. People seem to have trouble with that, and I think it's easy, but everybody always makes it harder than it actually is. Find scale factors of 2 shapes. Solve real-life problems using similar figures. As we go through this chapter, what we do today, it's just sort of to give you an overview of everything, and then we'll get into more rules and stuff where you won't have to do all the silliness that we do today and next class. So follow along, but a lot of this, except for the scale factor stuff, that's going to be real important. But some of the other stuff, maybe not quite as important because we'll learn other ways to do those same things that are a little easier.
Yes.
Back up here. Don't write any of this down, just follow along. I've never seen the movie. I got this from
You've never seen the movie?
Mr. Harrison.
It's awesome.
So this is probably a PowerPoint that I stole from him. In the movie,
Austin Powers.
what was supposed to be true about these two guys?
They were the exact same.
They were the
Just
exact-
1/8 of the size.
They were supposed to be the exact same. All right? Did they come out to be the exact same?
No.
No. And
Heel.
when we were talking about triangles, proving triangles congruent, they had to be exactly the same shape and the same size to be congruent. Well, when we talk about similar, that's this idea. These two are the same shape, supposedly, supposed to look identical to each other, but what's different about them?
You just want information.
They're different sizes. All right? So that's what similar is. Similar figures, and we'll write this on the next slide. Similar means they're the same shape, but they could be different sizes. That's what similar is. When two things are similar, same shape, but different sizes. All right, I forgot to put this in. So right here next to this, right, similar, that goes right here. That's the definition of similar. Where do you see things that are the same shape, not necessarily the same size a lot?
Cars.
Cars. All right, if you have a model car,
Polygons.
that's true, but somewhere else.
Basketball.
How about pictures? When you take a picture of somebody, is it the same size?
Unless you get like a fat head.
Right. And then it's not even the same probably. It's, a lot of them are bigger than the actual. So,
I want to get a fat head.
same shape. Right, polygons that have the same shape, so they're going to have the same shape, but they could be different in size. They don't have to be different in size, but if they're the same size, what's their scale factor going to be? 1. Right? So if you have two triangles and they're exactly the same, when we were doing congruent triangles, their scale, they did have a scale factor, but it was always 1. Because if this side over here was 5, then the corresponding side had to be 5. This right here is probably the most important thing that you're going to learn in this chapter.
Similar.
Two polygons are similar if and only if, and it's just these two things. Corresponding angles are congruent. That's the first thing. If I tell you that these two triangles or two polygons, whatever they are similar, the angles that match up still have to be congruent to each other. The second thing, corresponding sides are proportional. This little tilde, I'm going to come back to this here in a second. This little tilde is the symbol for similar. All it is the top part of a congruent symbol. So you just get rid of the equal to part, and that means they're similar to each other. How many sides does A, B, C, D have?
4.
4. If I draw this, A, B, C, D, hopefully it'll let me draw it. Then I draw another one. This is Q, R, S, T. This tells us that those two are similar. What this up here means, if I told you angle A right here was 70 degrees,
Q is 30.
Q has to be 70 degrees. So the angles are still exactly the same. If I told you B was 93 degrees,
You know R is 90.
R has to be 93 degrees. Alright, so corresponding angles have to be congruent. Now, if I tell you segment AB is 10, does that mean segment QR has to be 10?
No.
No. So let's say segment QR is 20. Then I tell you segment BC is 5,
You know that
RS
RS is.
RS is 10, because those sides have to be proportional to each other. So 10 has to compare to 20. This compares to this, the same as this compares to that. So 5 compares to what you guys just told me was 10 there. All right? Sides are proportional. Angles, corresponding angles, are equal or congruent with each other. Go ahead and write this down. We're going to talk about scale factor. We're going to write some stuff under reduction and enlargement here in just a minute. Sorry. We talked about triangles like this earlier this year. It looks like that each of these triangles is what kind of triangle?
A equal.
Equilateral. If each one, if this is an equilateral triangle, all sides are equal, what do you know about these angles? They're all 60 degrees. If I tell you that this triangle is similar to that triangle, what do you know about each of these angles?
60 degrees.
They're all 60 degrees. Now, does that mean if this side over here is 10, that the sides in this other triangle are all 10?
No.
So make sure, you see, that's where it's the same shape. They're both equilateral triangles, but they're two different sizes. That's what makes something similar. Reduction. Real quick on scale factor. We're going to talk about scale factor down here too. Scale factor is the ratio. We talked about ratios last time. Ratio of any pair of corresponding sides. You pick two sides that match up, set up a ratio. Reduction, if you're reducing something, what are you doing to it? Making it smaller. Now, with a reduction, scale factor is between 0 and 1. To make something smaller, your scale factor has to be between 0 and 1. And I'm going to write this down here. I almost hate to write it down here, but it seems to help sometimes. If it's between 0 and 1, what's it going to be? A fraction. Now, the reason I hate to write it down, are there fractions that are bigger than 1?
Yeah.
Yeah. So, remember that when we get to enlargement. So, examples of scale factor here. Some examples. You might have something that has 1/4 scale factor. That means you're making the shape smaller. You may have a scale factor of 2/3. Scale factor of 3/8. 3/8 is a big one. Brian said earlier, cars, 3/8 scale model is like a normal model that you use a lot. Those are the ones that collectors look for. 3/8 scale or
A lot of pipes are in 3/8 too.
right.
3/8 of them.
So 3/8 scale is something that a lot of people use. An enlargement. What are you doing when you enlarge something?
Making it bigger.
Making it bigger, good. Making it bigger, guess what's true about the scale factor?
Between 1 and infinite.
Alright, scale factor is more than 1. So it's bigger than 1. So give me something that could be an example of a scale factor to make something larger. 3, 2, 80,000, 1.1. Is that all right?
Yeah.
Now 1.1 is the same as 1 and 1/10, which is 11/10. This is where I don't like writing fraction over here, but it seems to help a lot of people. Is 11/10? Is that making it bigger or smaller?
Bigger.
Bigger.
Because 11's bigger.
All right, because the top number is
Have that extra note.
bigger.
1.
So scale factor.
0, 0, 0, 0, 1.
If you knew that these all were 10s, maybe this over here was 3.
The scale factor is.
What would the scale factor be? Pick any two sides that match up.
Is it
3/10.
All right, 3 to 10, maybe. What's wrong with that? What? Because I didn't give you quite enough information. What do you need to know?
Which one's making a scale factor?
Right, which one you're starting with, which shape you're starting with. A lot of problems, if you wrote down, if this was the problem and you wrote down 3/10, I'd probably accept that. What's the other answer I'd probably accept? 10/3. All right, one of those, because I have to be explicit and tell you, hey, this is the original shape, this is the new shape. If I'm not being explicit and telling you that, then I can't mark either one of these two wrong. If I just say find the scale factor of those two shapes, well, it's either 3 to 10 or 10 to 3, because we don't know if we enlarged or if we reduced the shapes. Now, if I told you I took a picture of Faith and it was at a scale factor of, or in the picture, we had all of Faith on here and it went from the top of her head to the bottom and we were trying to find her height. Is this going to be an enlargement or a reduction?
A reduction.
A reduction, so we know the scale factor should be something like 1 to 12 or whatever it is. All right, so then it should be a reduction. So some, all right, draw those two pictures and we're going to decide if these are similar or not. I can start working. So draw them. We're going to decide whether they're similar. Sorry, can't read that. Now, most of the stuff as we get into triangles, it won't take this much work to show that two things are similar, but for these, it's going to take a little more. For these to be similar, what has to be true about all corresponding angles?
We want the congruent.
So angle A over here should be congruent to what? Is it? Yeah. Angle B should be congruent to F. C should be congruent to G. D should be congruent to H. So to show that, if they wanted you to show it, all corresponding angles congruent. That'd be good enough for me if they show it all to you on there. So that's half of it. That's the first thing. To be similar, what has to be true about the sides? They all have to be proportional. 3 over here matches up to what in the other one? 9 over 2. I know most of you probably won't like that. You have a compound fraction, but it's not going to be that difficult.
What do you do with a mixed figure?
You could make it like 4.5, 4.5. I'm not going to write it that way for now. give me another side in this first one.
4.
4, and that matches up to what? 6. Give me another side over here.
4.
4, what's it match up to? 6, and the last one?
3 and 9 over 2.
Now you know these two are the same because they look exactly the same. You know these two are the same because they look exactly the same. But do we know that these two are the same?
No.
No. Again, if you have a calculator that does fractions, you could just do it that way. Otherwise, we're going to cross multiply here. If you wanted to change it to 4.5, you could. Sometimes, depending on the fraction, you can't do that. What's 6 times 3? So this going the other way should be 18. That's 4 over 1 times 9 over 2. Don't make fractions harder than they actually are. What is 4 times 9? 36. What's 1 times 2? What is 36 divided by 2? Since your cross multiplying came out to be the same there, guess what's true about those? They're equal, they're proportional to each other. So are the sides proportional? Yes. Are these two shapes, four-sided figures, proportional? Yes. Or are they, I'm sorry, are they similar? Yes. Yes, are similar. But that's what you gotta do. You gotta show the angles are congruent, sides are at equal ratios or proportional to each other. All right, draw this picture, or these two pictures. Make sure, be careful as you're marking them. This is more like what we're going to do, even though these are quadrilaterals. Most of the chapter will be dealing with triangles.
Mr. Wendell.
I'm gonna have to draw this.
Oh, you want us to actually draw it?
Mr.
I was just
Wendell,
gonna sit there
what?
waiting for the
You already phoned your house?
phone home.
Did it help any? Apparently it did if you're up to this whole.
I'm always up doing his homework.
Apparently you weren't before.
No, I didn't want to do work. Well, sick.
What?
I didn't want to do any work.
Bless you.
Jeez. A, B, C, D.
All right, they tell us that these two shapes are similar to each other. And they want us to find, there's like 6 different things they want us to find. First thing that we're going to write is the similarity statement. In other words, the statement says this shape is similar to this other shape. Somebody name this shape over here on the left one. A, B, C, D. Now, just like when we were doing triangles and congruent, you've got to make sure you match up the parts that match up. So A over here matches up to what in that one?
E, F, G, H.
Everybody agree with that?
Yeah.
That's our similarity statement. That's part of our answer. Next thing they wanted us to find was X. Well, to find X, we got to set up a proportion. Pick me a side in this 4-sided figure. 14. What's it match up to in the other one?
X plus 5.
X plus 5. Everybody agree with that?
Yes.
How can you tell?
Because if you flip flop this.
All right. What I usually do, the 14's between the angle that's marked with 1 and the angle that's marked with 2. What's marked that way over here? X plus 5. Pick me another side over here.
10.
10. What's it match up to in the other?
X minus 3.
Now I set up my proportion this way. As I walked around and I looked at a lot of your guys' the homework and stuff, did you have to set it up the way I set it up?
No.
No. Now be careful. There's different ways that you can set it up, but are there different ways that are going to be wrong?
Yeah.
Yeah.
Like the 10 and the X minus 3 have to be on the top because
if you're doing it, I do it, this compares to that. I take one from this shape, then the other one that matches up to over there. You could do 14 compares to 10, so 14 over 10, and then do the other. All right? What I do very first thing, anytime I have a proportion that looks like this, put parentheses around it, good. Cross multiply. When I rewrite this, it's going to be 14 times x minus 3 equals 10 times x plus 5. Somebody distribute those and tell me what to write so I don't have to keep messing around. 14x 42 equals what do I do next?
Minus 10x.
Make sure you're getting all the x's on one side first. Whenever most of you are solving equations, that's where you make the mistake. You try to do the regular numbers first, then the x's, which is okay, but it seems to confuse you. So you got 4x minus 42 equals 50.
Plus 42 to each side.
Add 42 to both sides. 4x equals 92. Now what? Divide by 4. How many 4s are there in 92? You're not sure? Come up here and divide it. How many 4s in 9?
2.
Put a 2 up there. That's 8. Subtract those 2. How many 4s in 12? 3. That's 12. Comes out even, so 23. That's part of our answer. Or another part. They want us to find the length of segment FE. How would you go about finding the length of segment FE? Just plug it in. What do we get right there? 28, good. How about the length of segment HE? 20. And how about the length of segment GF?
23. No. 23.
23.
Well, because you wouldn't just put an X there for different sides. So.
Now, if you put an X there, does that mean it's the same X?
No. Because that would make GH.
So how could you find that? Now you set up your own proportion.
Great. More.
What was the ratio? Let's find the one here. The 14 matched up to what?
The
X
plus 5.
Which we know now is
28.
28. What's that reduced to?
1/2.
1/2. So we could reduce that down, maybe make the problem a little easier. What's going to match up to this side?
16.
16. That goes, 16 goes on top, and the question mark on bottom, right? That's what we're looking for. Some variable. I didn't stick an X in there because I don't want Brighton to get confused putting that X in there and think it's the same as the other X. What's going to go on bottom here? 32. So how long is segment GF? 32. Triangle has side lengths 3 meters, 5 meters, and 4 meters. So I have this triangle, 3 meters, 5 meters, 4 meters. Triangle is enlarged so that the larger triangle, so we're making it bigger, is a scale factor of 5. So scale factor is 5. Find the perimeter of the new triangle. If the scale factor is 5, what do you do with each of these numbers?
Multiply them by 5.
Multiply it by 5. Now, what if the scale factor was 1/5?
Then you would multiply them by 0.2.
Okay, if you wanted to do it that way, or multiply by 1/5. Just take each number times whatever that scale factor is. That's going to give it to you. What's the length of this side in this triangle then? 15. How about this side? 20. This side? Now, they wanted the perimeter of that triangle. What do you gotta do to find the perimeter?
Add them all up.
What's 15 and 25? 40. 60 total, so 60 meters. Let's do this real quick. What's the perimeter over here? 12. Guess what's true about the perimeters?
They're 1/5. Well, like, there's a scale factor.
The scale factor of 5. What's 12 times 5?
60.
60. So, did we have to go through and find all of these three? No, we could have just took this, and that's going to be a rule we're going to learn later on in the chapter. This perimeter, took it times the scale factor, and that give us this new perimeter, and we wouldn't have to found any of the sides. Yep. All right, any piece of scrap paper. I'll tell you what. Would you guys rather have the last 12 minutes to make sure you got the test and the crossword done?
Yeah, sorry.
All right. So I'll do that for you. I forgot to tell my friends what class is. 293 also on Moodle. OGT quiz number 2. So those two things. 293 OGT quiz number 2. By the end of class, up there on that little desk, sitting right up there, your redo on your test and the crossword puzzle. Redo on the test and the crossword puzzle. Anybody who watched the video, was it helpful?
Yes, like the ones that don't
Right, and you could probably ask me right now if you want.
Okay, sweet.
Is the crossword due like right now?
Yep.
Okay.
I think I just want
As soon as you see Circum Center. What's that good with? Somebody help me out. What's Circum Center go with?
Perpendicular bisector.
So E is the Circum Center. That's telling us that this right here is a perpendicular bisector. So we know that these two segments are congruent. And what do we know about these angles?
I think it looks like flob.
MTG is right there. So what do we know about MTG? Is that going to let you find X?
Sorry, I'm
Yeah, what's it look like?
About
Flob?
like
trying to,
I don't understand.
I don't
Yeah,
know.
I think they go X like that when you go to these two equal to each other. Yeah, okay.
Dude, Nick,
I have this, and I second guessed
I'm running
myself.
on what's in there. I have like 10 words left to write on this.
Front. 108 divided by 12. And I hate to get that.
That'll sound right. No, it's not really.
Wait, okay, hold on.
You added instead of subtracting. You would really subtract. You add.
Dang it. That's maybe what I did wrong in this sense. I do that. Let's see. 72.
I'm not sure when the OGT quiz 2 shuts down. I know quiz 1 shuts down here in a couple days, so if you haven't done it, make sure you get on there and do it. I believe the other two, the vocab and the other quiz that we did last week or week before, I think they're both shut down, so hopefully you got on there and finished those.
You just do like the angle and then the opposite side.
Yeah. Bigger angles always across the longer side.
And then you just can't like give me the zero first second. I mean, I think they're right. That's after I have it.
It says triangle with all sides and all angles and everything, and they both look the
Regular.
same. There's way too long for it.
Equidistant. They're not equal.
I said equilateral. Equal language doesn't work for
Our
this
binder
one,
is getting really big.
because they're both the same thing.
Well,
There's longer than equilateral. Equilateral is
Which number?
5. 5 and 9.
Equilateral is this one, 5, because it says all sides.
So I thought, when it said all angles,
That's equal angular.
equal angle is
But those,
too long.
Spell right.
which one is that coming down?
Just shut the master of the cell. Probably just like missing a box of the actual thing.
No, no, L in it.
Equal angle.
Angular?
Equal angular.
Yeah.